All right, let's have a look at question number 4 now, which is related to thermal physics. All right, let me zoom in a little, sorry. That should be better. Okay. Let's do it this way. Now, here we are. Let's have a look. Evaporation of water from the surface of the skin causes cooling. Now, describe using ideas about the particles. Now, you have to refer to the particles, right? How evaporation causes cooling. Now, remember the context. Some of you know the answers, like why evaporation causes cooling, and you're going to think about generally the liquid that like for instance a hot cup of tea. Remember, that's the example we discussed in the classroom, or a hot cocoa or something. But now this time the reference is how does evaporation from the skin causes cooling, which is pretty much the same. Ideas are the same, and remember giving reference to the particles. So the answer that I'm looking for over here is that the high energy particles, since it's 2 marks, right? The high energy particles, the ones which have above average kinetic energy, are able to overcome the forces of attraction and leave the liquid from the surface of the liquid, right? And since the average energy of the liquid that remains behind, which is the skin in this case, the water on the skin or the sweat, overall the temperature, since the overall energy has decreased, it causes cooling. So let's see if we have the answer over here for this. High kinetic energy particles escape the surface, from the surface of the liquid, of the liquid. Now, not that I'm going to deduct any marks for not writing that, but it would be nicer if you did. Leaving behind slower or energy particles, leaving an overall cooling effect because the overall energy has decreased. 2 points are there, but just barely. It's not in a glorious way, but the points are there nonetheless. State one difference between evaporation and boiling. Evaporation occurs at all temperatures. That's true. Below the boiling point, whereas boiling occurs at fixed temperatures. That is a good point. So let's see. I'm just going to see if evaporation occurs only at the surface and only to particles who gain enough energy to break their bonds with others. This causes cooling, as they cannot transfer the kinetic energy to the particles leaving the water before they can do it. Okay. The points are very well much there, very good, because the high energy particles have left the liquid, low energy particles are left behind, overall a decrease in energy. Good points. Those points are there. Occurs throughout the liquid. Evaporation occurs only at the surface. Again, good points. Let's see who else has done it. As the particles with the most energy at the top of the surface. Now, it's not necessarily they are able to leave from the surface, so even escape the water altogether. It decreases the average kinetic energy very, very well. It decreases the kinetic energy of the particles in the water and a cooling effect. Very, very good. Evaporation does not have a fixed value, temperature point, whereas boiling has a fixed temperature point, boiling point at which. Excellent, very well said. When a refrigerator is switched on, cooling coils placed at the top of the space, which is this, inside the refrigerator becomes cold. This causes a convection current, which cools the air inside the refrigerator. Okay, so the refrigerator is shown in figure 4.1. Explain how the cooling coils cause a convection current in the air inside the refrigerator. Now, the air which makes contact with the cooling coils gets cold. All right, when it gets cold, its density decreases. As its density increases because it contracts. Its density increases, which causes it to sink down. And this air is now displaced by a hotter air which starts cooling, and that's how the cycle is. As the less dense hot air rises to the top of the refrigerator, the cooling coils cool the air to make it denser and sink. Very good. Cool the air to make it denser and sink down while pushing the hot air up again. Excellent. Very well said. Now let's look at this person now. As hot air rises, it comes into contact with the cooling coil, and through conduction. Very good. Not even required, but they transfer their thermal energy into the cooling coils. This causes particles to become dense, or spaces between them are reduced. They push the hot air as it has. So it sinks. It would have been nicer if you said sinks. All the answers are there. I understand your physics is good, but you haven't said that they're sinking. The hot air and thus lower density causing, and then that the denser, the colder, denser air sinks. That is what you should have said, but you haven't said that. But I know that you know your physics. We're going to get this point. I hope the CAIE examiners will be that generous, but be careful. I mean, you're writing all this wonderful. Your concept of physics is good, but you have to say it outright. Yeah, so it's important instead of saying unnecessary stuff. That's important. Let's see what you've done. Obviously, this is not the right answer. So you've got the formula right. Very good for that. All right. So I'm just going to give you a mark over there, but because there is no answer, but I can see. Let's find out where your mistake is. This is your C. The energy is over here, which is good. You've put that right into the equation. The mass is right in kilograms. What you should have done over here would have been to write delta theta, right? Delta theta, which means the change in temperature, which is theta 2 minus theta 1. Since you have theta 2 is 20 degrees Celsius, finally you could have just subtracted your answer, which would be, I think it's 14 point something. And yeah, so I think you got almost right. Look, you got the answer right. 20 minus 14.8 should have been 5 point something, yeah? And 2. And you did it right, but somehow 14.8 minus 20 is not 34.8. I don't know how you got that. So this is where the mistake finally is. All right, you did not know how to subtract. But your physics was good. 1, 2, 3, 4, 5, 6 out of 7. All right, and let's look at the air particles contract, become more dense, and fall. Air particles do not contract. Right, they get closer together. The air particles don't. This insinuates that the size of the particle decreases. It doesn't happen. It's not the size. It's the space between the particles that decreases. Become more dense. The air becomes more dense. So you'll fall, replacing the particles beneath this process and repeat causes convectional currents. Your physics, be careful with this, all right? Don't insinuate that it's the particles that contract. All right, and this is right, because you see you did it like delta theta, that is 20 minus t, and you got that right. Very good. 14.81, and then you subtracted it and you got 5.12. Excellent. Good job. So that's it's 6 out of 7, but you know, avoid that mistake. But your explanation is good enough. You do get a 7, but avoid that. All right, let's look at this. Brilliantly done again. Good job there. I like the order in which you write the formula. You put the values in the formula, then you got your answer there, and then you finally, excellent. All right, that's 7 out of 7. Keep it up. All right, I'm not lucky. I'm trying to get some of the random papers. So